Okay, so in your notes, so we've talked about Coulomb's law, shielding effect, effective nuclear charge. So along with those and this top little concept at the top of your paper, that's what makes our trend. So all atoms we know want to have how many electrons in their outermost shell? How many electrons does everybody want to have? Because they want to be like a noble gas. 8. Good. Okay. Your atomic radius is just the size of your atom. Okay. And so what that means is you have the little nucleus, and then you have your little electron cloud. It's from the center of nucleus out to your outermost electron, which is called a valence electron. Okay. Now, when you guys were looking at your different radii, whatever, who was your biggest atom on the periodic table? Who remembers? Yeah, that guy. Yeah, francium. Good. So put a big B in that little left-hand corner. This is the big corner. This up here is the small corner. I've had students in the past who wanted to put a big R and a little r too. If that makes more sense to you, you're more than welcome to. I just do big, small. They want like big radius, little radius. I don't know. It's up to you. Whatever you want.
Wait, so it's radius?
Yes. That's. All right. So as you move across, you are increasing or decreasing? Decreasing. Okay. And the reason why, is it because you are adding energy levels like shields, or is it because you're adding protons? You're adding protons. So that is going to be Zeph. That's your reasoning. Okay. Because of Zeph. And what Zeph is, we're going to go in this more detail tomorrow, okay? But what Zeph is that effective nuclear charge, meaning your nucleus gets more charged, okay? Going down the periodic table, we are getting bigger, so we are increasing. And that's because of what? Shielding, yeah, shielding effect. Okay. All right. I wrote that very ugly. I'm so sorry. Okay. For ionic radius, who remembers what the special line was for this one? You could only go to a certain line. The stair-stepper line, right? Right here. Just make yourself a little squiggly. It doesn't have to be pretty. All right? That little line, that is our metalloids line, right? So you can only compare cations with cations. So your cations are on this side. Are cations positive, by the way, or negative? Positive, right? Remember with a little t in the middle. And then your anions are over here. Okay? Those are the negative ones. Cations are your positive. But, so basically, your anions are always going to be bigger than your cations. And that's because as you add another electron into this already full cloud of electrons, it's going to poof out even bigger, all right? So anions are the bigger ions, if you will, okay? But that general trend with the size of your ions is that you still have a big corner and a small corner. It just kind of starts over at that metalloids line, okay? And I know it's hard to find the corner on that one, but it starts at carbon. Carbon is huge. That was the one that yesterday we were looking at had 260. Okay, whereas our biggest one, francium, is only like 160. Okay? All right. So overall, radius decreases across, increases going down. It's the same for both. Ionization energy. Who remembers what that energy was? The energy required to not gain, the opposite? Lose, to remove an electron. So if you can picture yourself just like walking up to an atom and trying to steal their electron, this is telling you how much energy are you going to have to do. So is it handed to you, or do you actually have to like fight the atom to get their electron from them? Okay? Who do you for sure have to fight to get their electron?
Noble gases.
noble gases, for sure, for sure. Absolutely. These guys, huge, all right? So they get a huge heart over here. But who would be your next non-noble gas? Fluorine, exactly. So fluorine is holding on for dear life, okay? And that's actually going to be important when we get to acids and bases. The fact that he holds on so much is why it's actually going to be considered hydrofluoric acid is a weak acid. It does a lot of damage, but it's a weak acid because it's going to hold on so tight. Okay? And then francium, if you remember, he had nothing. Right? His was on the street for free, probably pay you to take his stuff. That's kind of what he's doing. Yes, yes. He had negative energy required. So, all right. So, little corner, big corner, okay? So across we are increasing, and going down a group we are decreasing. Okay? And we're going to see that increasing across is still because of Zeph, or the increasing protons, and the going down one is still because of the shielding effect. That's the argument for this. All right, electronegativity was, there you go, was your atom's ability to attract electrons. And I told you yesterday, this number actually only becomes important when you're bonding. So we really don't even include our noble gases because they're not usually going to bond with anybody. There's an exception when you get lower on the periodic table, okay? But when you are trying to bond with it, who is going to want every electron possible?
The fluorine.
Yes, so we're going to put a big heart on him again. Man, that is not showing up.
Why can't it be a her?
You just assume it's gender.
Actually, technically, yes. In one of my sayings, it is a her. Francium. Francium is the dude. Yeah, you're right. I don't know. All right, and then francium gets the little heart, okay? Does not really need any electrons, wants to get rid of it as much as possible, okay? So, again, we are increasing across due to that increase of protons, increasing the number of protons, and we are going to decrease going down because we are adding more and more shields, or more and more shells, okay? And so that's what you were supposed to get from the little thing yesterday. Cool? Cool. Do you guys have any questions?